Good morning, Year 10. So this is your Do Now activity for today's lesson. So pause the video here, answer these 3 questions, and then come back to the video and we'll go through the answers. Okay, so hopefully you've answered these 3 questions now. So I'll go through the answers. Number 1, what are the 8 planets in order? So the answer is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Okay, so give yourself a mark if you got that one right. Number 2, name the electromagnetic waves in order from the longest wavelength to the shortest wavelength. Okay, so that means we start with radio waves, and in order, getting shorter. So it's radio waves, microwaves, infrared, visible light, ultraviolet, which I'm going to shorten to UV, X-ray, and gamma. Okay, so that's the order going from the longest wavelength to the shortest wavelength. So it's radio, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. And then number 3, label the parts of this wave diagram. So you've got a little box with the words you have to put on the diagram. So let's put those on. So this point here is the peak. This point here, the lowest point, is the trough. This section here is the amplitude, and this section here is the wavelength. Okay, so if you got all of that right, give yourself a mark out of 3, and we'll move on to today's lesson. So today's lesson is about the universe. Today's date is DDI Pedwar Chwefro. Your learning objective for today is to understand how theories about the universe have changed over time. And your keywords for today are the Big Bang Theory, the Steady State Theory, Cosmic Microwave Background Radiation, and Red Shift. So there are 2 main theories about how the universe started. That is the Big Bang Theory and the Steady State Theory. And some common evidence we use for these theories are redshift and cosmic microwave background radiation. So these 2 pieces of evidence will either prove or disprove what we think about the 2 theories. Okay, so first up we're going to look at the Big Bang Theory. So scientists have gathered a lot of evidence and information about the universe, and they have used their observations to develop a theory called the Big Bang Theory. So this theory states that about 13.7 billion years ago, all of the matter in the universe was concentrated into one single, incredibly tiny, hot and dense point. This began to enlarge rapidly in a hot explosion, and it is still expanding today. So the theory is that the universe started from one tiny point. There was a big explosion, and it created the universe, and the universe is still expanding today. So that's the Big Bang Theory. The evidence for the Big Bang includes all other galaxies are moving away from us, and the further away a galaxy is, the faster it is moving away. These 2 features are commonly found in explosions, The fastest moving objects end up the furthest away from the explosion. Scientists have also detected cosmic microwave background radiation, or CMBR. This is received from all parts of the universe, and it is thought to be the heat left over from the original Big Bang explosion. So now is the first review of the lesson. So there's 4 questions, so I want you to pause the video here, answer those 4 questions, and then come back and we'll go through the answers. Okay, so hopefully you've answered those 4 questions now. We're going to go through the answers. Number 1, what is the Big Bang Theory? So the Big Bang Theory states that 13.7 billion years ago, all matter was condensed in one tiny dense point. A hot explosion caused it to enlarge, and it is still expanding today. Okay, so the Big Bang Theory is 13.7 billion years ago, all matter was condensed in one tiny dense point. A hot explosion caused it to enlarge, and it is still expanding today. Okay? So question 2, what are the main 2 pieces of evidence for the Big Bang Theory? So we said the first one was all other galaxies are moving away from us. And the second piece of evidence is the further away a galaxy is, the faster it is moving away. Okay, so these 2 things are proof that there was an explosion, because those 2 things are commonly found in other explosions. Number 3, how long ago did the Big Bang Theory take place? We also answered this in the first one, so the answer is 13.7 billion years ago. And finally, number 4, what does CMBR stand for? It stands for cosmic microwave background radiation. Okay, so we'll look at CMBR in a bit more detail later on in the lesson. So give yourself a mark out of 4 for these questions and we'll move on. Okay, so one of the things that we've used to prove the Big Bang Theory is something called red shift. Okay, so you can see this rainbow spectrum, that's the visible light spectrum, but as you can see there are some black lines through it. So our sun contains helium, and we know that because there are black lines in this spectrum, which means that the helium from the sun has absorbed the light at those frequencies. So these lines form the absorption spectrum for helium. And when we look at that spectrum of a distant star, the absorption spectrum is there, but the patterns of the lines have moved or shifted towards the red end of the spectrum. So we call that red shift. So it's a change in the frequency of the position of the lines in the absorption spectrum. Okay, so we'll look at the difference between the normal spectrum and the spectrum of a distant star in a second. Okay, so here we go. This top one is what we would normally see from our sun, and the bottom one is the absorption spectrum of a distant star. So as you can see, these two lines have shifted over there, this one shifted there, this one shifted there, and so on. All of the lines have shifted closer towards the red end of the spectrum, okay? So that's what redshift is. All of these frequencies on the absorption spectrum move towards the red end of the spectrum. So astronomers have discovered that the further away a galaxy is, the more redshifted the light is. This means that the further away the galaxies are, the faster they are moving. This is similar to an explosion. The bits moving the fastest travel the furthest from the explosion. So the redshift data provides evidence that the universe is expanding, which is what the Big Bang Theory states. So now we're going to look at CMBR. So remember, CMBR stands for Cosmic Microwave Background Radiation. Astronomers have discovered that this comes from all directions in space. Scientists think that the Big Bang explosion produced a lot of energy in waves of different wavelengths, ranging from high frequency radiation like gamma rays to lower frequency radiation like microwaves. As time has gone on, these waves have become more thinly spread across the whole universe, and scientists think that CMBR is the remains of that thermal energy from the Big Bang that's coming to Earth and all over space. The discovery of CMBR provided very strong support for the Big Bang Theory and led to the Big Bang becoming the currently accepted model of the development of the universe. Okay, so now here's review 2. You've got another 4 questions, so pause the video here, go and answer those, and then we'll go through them in a sec. Okay, so hopefully you've answered those 4 questions. Now I'll go through the answers. Number 1, what is redshift? So redshift is the change in frequency of the of the black lines towards the red end of the absorption spectrum. Okay, so the redshift is the change in frequency of the position of the black lines towards the red end of the absorption spectrum. Number 2, what do astronomers believe is the link between galaxies and redshift? So the answer is the further away a galaxy is, the more redshifted the light is. So the further away a galaxy is, the more redshifted the light is. So that's the link between galaxies and redshift. Number 3, what do the black lines on the light spectrum from the sun represent? And the answer is helium absorption. So the black lines are where the helium has absorbed the light. And finally, number 4, what is CMBR? So I didn't want you to say what it stood for because we did that in review 1. So for this question, I wanted you to say what scientists believe CMBR to be. So they think it is the Okay, so CMBR is the remains of the thermal energy from the Big Bang coming from all directions. So give yourselves a mark for each of these questions you got right, and then we'll move on to the next part. There is another theory about the universe called the steady state theory, which says that the universe has always existed and that the universe is expanding and constantly creating matter as the universe expands. So this idea is supported by the redshift evidence, but not by the CMBR evidence. So after the discovery of the CMBR, the steady state theory lost support and is no longer considered likely. So here's a table to show the comparison in the evidence. So for the Big Bang theory, the evidence observed is that more distant galaxies have greater redshift, and that CMBR is everywhere coming from space. And the evidence to support steady state theory is more distant galaxies have greater redshift, but CMBR is everywhere coming from space does not support the steady state theory, okay? So for the Big Bang theory, both evidences apply, but for steady state theory, only the redshift applies, the CMBR does not apply, okay? So review 3, it's another 3 questions, so pause the video here to answer these 3 questions and then I'll go through the answers. Okay, so hopefully you've answered those 3 questions. I'm going to write in the answers now. Number 1, what is the steady state theory? So it is that the universe has always existed and is expanding constantly. Creating matter as the universe expands. Okay, so the steady state theory is that the universe has always existed and is expanding constantly, creating matter as the universe expands. Number 2, what evidence supports both the Big Bang theory and the steady state theory? So that is redshift. And number 3, what evidence does not support the steady state theory? And that is CMBR. Okay, so give yourself a mark out of 3 for those questions. And finally for this lesson, I've set 2 exam questions. So one of them is a QWC question talking about the evidences for the Big Bang theory, and the other question is talking about redshift and the different wavelengths and frequencies of the absorption spectrums, and then it moves on to talk about CMBR at the bottom. So those are in your class notebook assignments, so please complete those questions and then hand in all of your work for today. Thank you!